Hello, welcome to my video. What I want to do is show you how to find the rational zeros. It's so exciting. I'm telling you, this ain't so bad. But why do we do this when we have technology at our side, right? When I have a calculator, I have Google that. All you gotta do is type it in and I find the zeros. Well, the reason why we're going to work on this is, from stuff that we've already learned, it applies to now looking into finding the zeros. So even technology is great, and I'm going to incorporate that into showing you how to find the zeros. It's also important just to understand that where did these zeros come from and how do we use what the information we already knew. How do we use synthetic division? How do we use the remainder theorem? How do those come into play to help us find the zeros of a higher ordered polynomial? So right now I have f of x equals x to the fourth minus 13x squared minus 12x, and I want to find the zeros. So the first thing I'm going to do is I'm going to actually use the rational zero test. And the rational zero test is going to tell us all the possible rational zeros of that function. Now, it doesn't tell us if they're zeros or not, but it tells us if we have zeros that are rational, it has to be the ones that we're going to get. So first of all, the rational zero test is p over q, where p is the factors of all your constant and q is the factors of all your leading coefficient. You notice up here I do not have a constant, so therefore I'd have 0. Therefore, leaving me with no rational zeros, which is going to be tough because I don't know. Actually, we might be able to look into factoring. Actually, we could use substitution and we could use quadratic formula for this, or maybe possibly actually even a factoring technique as well. However, let's factor out an x. So we get x cubed minus 13x minus 12. So when I factor out an x, that's what I'm left with. And ooh, yeah, we're not going to be able to do that actually because I have an x at the end. So that's a good thing I factored this out because I can't use quadratic formula because I still don't have a constant, nor would a factoring technique work. However, when I factor out the x, I do notice now I can use, how about I use this function I deal with, so we know x is going to be a 0, but we also know now here is my p, and my q is still going to be 1, which is the coefficient of x cubed. So I have plus or minus the factors of 12, which are plus or minus 12, plus or minus 6, plus or minus 4, comma, plus or minus 3, plus or minus 2, comma, plus or minus 1. So those are all the possible rational zeros. And I don't even know even if they're true. I didn't write q because the plus or minus q is 1. So all of these divided by 1 are all going to be your whole numbers. But let's look at all the possible rational zeros. And we don't even know if they're real zeros anyways. 2, 4, 6, 8, 10, 12. That means you have 12 possibilities. So without technology, what would you do? You would have to verify these as zeros by either using synthetic division or by using the remainder theorem. Remainder theorem, you plug in each one of those zeros into the function and see if you get 0. And synthetic division would be obviously synthetically divide and see if you get a remainder of 0. Now, what I did was I used my graphing calculator. Actually, I used Google on my computer, and I graphed the function to see what it looked like. And I looked at what the zeros were. And I didn't want to get exactly the zeros, but it was pretty easy to see, OK, I have some rational zeros that I believe are going to be true. But you have to make sure you verify them algebraically. So I'm going to take my zeros to be at -3, because that's what I want to show you how to do. Use synthetic division. So when I graphed it, it looks like the graph crossed. Graph looks something like this, I think. So it looked like it graphed somewhere at -3. So let's try synthetic division, and let's check it out. So I'm going to go back to synthetic division to my original polynomial, which would be 1, 0, -13, and -12. Remember, you got to have a placeholder. So what I have here is bring down the 1. 1 times -3 is -3. -3 plus 0 is -3. -3 times -3 is going to be a positive 9. -3 plus 9 is going to be a -4. -4 times 3 is going to be a positive 12. Pretty cool, right? So therefore, now I have my factor at 1, -3, -4. Now, we can continue to synthetically divide, right? I said I think -1 is another factor. But you guys can also see, if I rewrite this as an answer, x squared minus 3x minus 4, hopefully you guys already know that this is going to be factorable. Right? So we could factor it already to there. So now I can write my factors as, so I can now write my polynomial as a product of its factors. And therefore, now I can write my zeros as 4, -1, and -3. So there you go, ladies and gentlemen. That's how you use technology, which I didn't show you how to do. There's other stuff for there. But use technology, the rational zero test, to find your zeros and remaining zeros. Thanks.